Assalamualaikum. Can you hear me? Didengar?
Yes, okay.
Nampak? Can you see?
Yes.
Okay. Bismillahirrahmanirrahim. Assalamualaikum and good afternoon. So we are still in past year exam question review 2013/2014. Okay. So we already we are not discussed question 1. Question 1 no need to answer. Please note question 1 is out of syllabus. That one is will be asked in the control system design. So question 1 no need to answer because it's out of syllabus. Question 2 we will discuss next week. Question 3 also will be discussed next week. Question 4 already discussed last 2 days. Okay, so question 5 no need to answer, out of syllabus. Okay, then we move to 2014-15. Okay, so question 1 we'll discuss next week. We go to question number 2. Okay, question number 2A. Angku Izzat.
Yes, Prof.
Baca kan.
The control engineer required to design a mechatronic system for optic and press operation. The objective is to have a fast and accurate positioning system, as this will increase plant productivity. For this project, 3 second-order mechatronic system A, B, and C are available. All plots of the system on the S-plane are shown in figure Q.2a. Which system should be chosen by the engineer to achieve the objective? Explain your answer by comparing time response specifications of the system.
B.
B. Capacitor is an energy storage element that charges and discharges voltage. During the charging phase, the voltage will be stored up to the input voltage. Figure Q.2b shown an RC circuit with the input voltage EIT equal to 5 volt and the resistor R equal to 2 kilo ohms. For control application, the capacitor voltage E naught T should settle down within 0.2 seconds, settling time 0.2 seconds. 1. Identify the capacitor value to achieve the requirement. Number 2. Sketch the time response for E naught T. C. A feedback system to control a DC motor is shown in figure Q.2C1, where RS and CS are the input and output respectively. The transfer functions are GS equal to 5 over S in bracket S plus 2, HS is equal to K. Figure Q.2C2 shows the unit step response of the closed loop system with K equal to 1. Although zero steady-state error is achieved, the system overshoot is unsatisfactory. For a specific application, the control system is required to have zero overshoot with the fastest response. You are given a task to determine the value of K to achieve this objective. Number 2, analyze the effects on the settling time and steady-state error of the system with the new K. And number 3, a steady-state error is an important criteria. Is it possible to determine the value of K so that the system operates at zero overshoot while maintaining zero steady-state error? Explain your answer.
Okay. So basically, this question will give you some idea how to face the quiz question on the 23rd of January, Sunday, 9 p.m. Okay, 5%. So we almost finish our assessment. Tomorrow is the due date for assignment submissions, and then followed by 23rd January quiz. And by 31st of January, you will get your carry marks for final exams. Right. So the objective is to have a fast and accurate positioning system. Okay, fast and accurate. For this project, we have 3 pair of complex conjugate poles. Am I right? 3 pair again of complex conjugate pole. Okay, can you see? Complex. Complex. Pair of poles. A, B, and C. So this is A, is a complex conjugate pole. C, also complex conjugate pole. B is a real pole. Okay. So in this case, we found that B is one on the left half plane, the other one is on the right half plane. Am I right? Betul tak? Hello? Hello?
Yes, Prof.
Yes, Prof.
Begitu, So meaning that B is out of question due to unstable. Okay, so B is no more in the scope of discussions because it is unstable. So unstable meaning the system is not accurate, not fast enough. So the only things left is D, A and C. Okay. For discussion. Can A and C are complex conjugate poles. Okay, complex conjugate poles. So in this case, we must compare the specifications in terms of TP and TS. What is TP? What is TS? Aisyah Shahira, what is TP? What is TS?
P is peak time and TS is settling time.
So TP is pi omega D. Omega D equal to Sharifah Khairunisa. Omega D equal to
Kejap tu.
But omega n multiplied 1 minus zeta square. Settling time? Settling time.
Settling time.
Okay. So we compare peak time, settling time, overshoot. Okay. So we have a system A and system B. Correct? So TP, peak time for A, if the complex conjugate poles is near to the imaginary axis, so A will be fast. And B is far away from the imaginary axis, so it will be slow. Settling times. So if A is near to the imaginary axis, so it takes time to settle down, so it is slow. And for B, which is far away from imaginary axis, settling time is fast. Overshoot for A, which is a complex conjugate poles near to the imaginary, the overshoot is high. And for B, which is far away from the imaginary axis, so the overshoot is low. So in this case, okay, so in this case, B pula. B is out of discussion. C. Hey, tidur budak-budak ni. Tak ada teguran pun. Hello? Hello?
Yes,
Prof.
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 Faham tak? A and C. Faham tak? Guys, faham tak?
Yes, Prof.
Okay, continue. Then kalau kita lihat di sini, if we plot the time response, okay, so let's say the A is like this, and B is like this. Okay, C and B, A, sorry. B is unstable, tak pakai, unstable. And so B tu dia unstable, maknanya dia is like this. It's bigger, 10 times towards infinity. Okay, so which one is better? Nabil,
Yes, doctor.
which one is better? A, B, or C?
C.
Why?
Because
Betul lah tu. C, sorry. Teruskan. C is better. Response due to Bill.
yes, doctor, due to faster settling time
And
and low
macam mana?
mark.
Salah. Bukan low mark. Awak ni mengikut je. Low apa?
Low peak time. Low.
Good. Low percentage overshoot.
Low percentage overshoot, doctor.
Kau baca je. Orang tulis low mark, kau baca low mark. Baca lah betul-betul. Okay. So next question is, so this one, okay, This one? So the circuits is shown here. What is this circuit? The name of this circuit? Aja nak tanya. Udah pandai tak? Udah tahun 3 kan? Ehsan Aulia, what is the name of the circuit?
Apa doktor tadi?
Circuitnya namanya apa Pak?
Kapasitas sirkuit.
Oh, salah tu. Salah tu. Afzal, ni circuit apa ni? Ada nama special tu dia. Special name.
RC circuit. Kita banding tak tu?
Ya, harus RC sirkuit doktor.
Oh, it's a type of filter. Apa namanya?
Oh, type of dia filter.
Nukman.
Yes, doctor.
It's a type of filter. What is the name of this filter? Habis. Habis. Aisyah Saleha.
Low pass filter.
Bagus. Beri tepukan. Low pass filter. Semua sebut. Everybody said.
Low pass
filter.
Tak dengar.
Low pass.
Low pass filter.
Pass filter.
Tak dengar. Can't hear you.
Low pass filter.
Low pass filter.
Low pass filter.
Okay. So what is the given in the circuit, in the question info? Zulfikar,
Yes, Prof.
info from the question. What is R?
Input.
Info apa? 5 volt. Kan?
Yes, Prof.
5 volt. Settling time. Zulfikar, settling time. Adakah soalan tu? Tak tahu. Azri? Azri Rukaini.
0.2 second.
Tak dengar lah.
0.2 second.
0.2. Isma? Isma?
Ya, Doktor.
KVL ni apa? Teacher voltage law.
IR IT darab R tambah IT darab C.
IT darab dengan C.
Oh, salah. Bukan. Ke I tambah?
Oh, yes.
Bukan dalam kurungan I1 tambah I2, Doktor.
Formula kapasitan apa? 1/C.
Oh, 1/C. Okay.
Aduh. Stres buah apa? Plus. Macam mana nak jadi engineer ni? Plus the KVL, you will get what? Nur Najwa?
IS plus 1/CS.
Ni, betul?
Yes.
Yes, thank you. Setuju? Agree? Agree or not?
Setuju. Agree.
Kalau tak semangat, next week tak payah kelas lah. Revise sendiri je boleh? Kalau tak semangat, revise sendiri boleh?
Tak boleh.
Tak boleh, Prof.
Boleh, Doktor.
Boleh, Doktor.
Bagus.
Ya, Doktor.
Inot dah.
E not equal to apa soalan tadi?
Tengok sikit je bah.
E not equal to 1/CS.
Ha?
Tak. Oh.
IS lah.
Ah.
Betul? So that's why IS jadi apa bang? Betul?
Betul.
Okay. Substitute. So substitute E2 in 1, kita dapat apa? Correct? Correct or not? Okay. Sama dengan apa, Pak? Okey.
Ya, Doktor.
Sama dengan apa?
1 over RCS plus
Plus
0.
Astagfirullah. Plus 1. Plus 1.
Oh yeah, plus 1.
Simplify.
One over RC over S plus 1 over RC.
Okay, guys, understand? So this system low pass filter ni what order? Henrita, what order?
First order.
Huh? Tak dengar apa? Huh?
Order 1.
First order.
Yeah.
Order. So first order ada time constant lah. What is time constant? Henrita?
Constant tau.
Apa dia? Definition. The time taken. The time taken for the output to reach 63%
63%
of the
of the
apa?
final value.
Or in this case, tau is equal to RC. Okay. Settling time. For tau. That is formula in the notes lah. Okay. So TS is equal to 4 tau. Is equal to 4 RC is equal to what? Henrita.
4 times R reading 2K.
Nah, 2K.
R punya value 2K kan?
Saat, 2 saat.
Oh, okay.
Tidur ke? Jangan tidur, bah. So C sama dengan berapa?
Doktor, sorry, bukan 0.2 second ke?
Ha?
Bukan 0.2 second ke?
Saja je test, tidur ke apa kan. Baguslah tu tak tidur. Bagus. Apa nama ni? Siapa nama?
Azim.
Hafiz Nazim. Bagus.
Ya.
Apa nak pace? Berapa pace dia punya tu? 0.2 divided by 4 multiplied by 2000. 0.2 divided by 8000 berapa?
2.5 darab 10 kuasa 5.
Macam mana? Sekali lagi.
2.5 darab 10 kuasa negatif 5.
Jadikan dia 10 kuasa negatif 6 mikro.
25 mikro.
Nur Najwa, mikro tu 10 kuasa berapa?
Negatif 6.
So what is the value of tau? Najwa, Nur Najwa.
Eh. Ah, 50 milli.
Berapa?
50 millisecond.
50 millisecond. So, you dah boleh agak dah dia punya sketch dia. Kan? Input berapa? Najwa lagi satu. Input dia berapa? Najwa. Najwa lagi satu. Tak datang. Tak datang.
Yes, Prof.
Tanya lah. Kalau tak tanya tak datang Ramai tak datang ni.
Ya. Apa soalannya?
Inputnya berapa?
Tak tahu, Prof.
5 volt kan?
Oh, 5 volt.
Input. Ni? Kan? Okay. Outputnya?
5 volt.
Apa pula outputnya 5 volt? Mana? Output. Kan? Jadi dia punya ni tadi berapa? 0.2 second. Dan tadi berapa? Najwa? Tahu sama dengan?
50 milli.
Logik tak? Logik tak? Logik
Logik.
Boleh diterima. Yes. C. C. Okay. Yeah, okay. You are given a block diagram and then you are given a time response. Kan? So this time response based on the assignment punya experience, first order ke, second order ke, third order? Zati?
Yes, Prof.
Based on the time response ni. First order ke, second order ke, third order?
Second order.
Second order type what? Undamp, overdamp, negative damp, critical damp.
Under them. Under them.
Under damp. Okay. So you are given GS and HS. Okay. Faham tak apa soalan tu? Okay. What is GS? GS is 5 over SS plus 2. Okay. What is HS? HS is equal to K. Okay. So the question, what is the question asked here? K equal to 1. 1. 0, steady state error is achieved. Right. Overshoot, unsatisfactory. Apa maksud unsatisfactory? Sarah, what do you understand by unsatisfactory?
Value dia tinggi.
English lah, English.
The value is high.
Okay. Dia one volt. So steady state error dia 0, right? K equal to 1. Steady state error 0, but overshoot high. And unsatisfactory, tidak memuaskan. Okay. Right? Faham? So, soalan ni nak apa For a specific application, the control system is required to have a zero overshoot with fastest response. You are given a task to determine the value of K to achieve this. So what is K? So that OS is equal to 0. Kan? Betul tak? So what is the formula of overshoot? Aisyah Akram?
Overshoot. Ada banyak Prof. Nak mana satu Prof?
Inilah.
Oh, yang tu. Dah lupa lah Prof. Sekejap.
Minus
exponent power of negative zeta pi bahagi set tu 1 minus zeta kuasa power of 2 close bracket darab 100. Betul.
OS only? OS only? No overshoot?
OS only tak ada darab 100. Still same but no times 100.
So if OS is equal to 0, what is the value of zeta?
Equal to 1. 0. 0 ke 1. Tapi nanti graf dia akan jadi melatakan.
Let zeta is equal to 1. So this one will be 1. And this one will be 0, alright? So dia akan jadi 1, betul tak? Exponent 0. Dia akan jadi apa? If zeta equal to 1.
Zeta equal to 1. Tapi kan Prof, bila saya masuk dalam calculator, dia bahagi with 0 tu tak boleh kan? Dia jadi
infinity lah. Infinity. So this is 0 lah kan? Okay. So maknanya for 0 overshoot, so zeta is equal to 1. Okay. Zeta equal to 1. Okay. So we find the closed loop transfer function. Syuhada, closed loop transfer function.
Dia closed loop, denominator tu tambah 5.
Plus one. Please don't disturb me. Okay, continue. Continue.
Denominator tu tambah 5.
S plus 2 plus
5. 5.
Huh? 5 multiplied by K. Sebab HS is G, H ni kan G1 plus GH kan. So this one is K. So 5 to multiply by 5K.
Okay.
So simplify. By K. Okay. Then compare. Okay. Sure dah. Macam mana nak compare? How to compare?
Tengok S.
Tengok 2 then in WN 2 equal to 2.
And
Macam tu.
macam tu. Okay. Correct. So K is equal to 0.2. Betul. To make the overshoot equal to 0. Okay. That is question number 1. Number 2, analyze the effect on the settling time and steady state error of the system with the new K. So macam mana nak analyze? Nabila, how to analyze? Nabila. Hai Nabila. Tak datang eh? Tak datang. Rida Hadirah. How to analyze? Rida Hadirah. Tak datang. Saiban, how to analyze when K is equal to 0.2? Yeah. Saiban.
Yeah, I'm not really sure.
How to analyze? We calculate the settling time first. 4 is equal to 1 multiplied by 1. Okay. 4 minutes, 4 seconds. And what is the steady state error? 1 minus 5. Using the formula, so we got 4 steady state error. But with all value of K, which is equal to 1, okay, 5 over s square plus 2s plus 5. Steady state is equal to 0. And settling time is equal to 4 divided by zeta omega n, which is equal to 4 seconds. Okay. So therefore, with the new K, instead of K equal to 1, 0 OS can be achieved. But steady state error is decrease or increase? Aisha Akram, is increase or decrease?
Decrease.
Increase.
No.
Tadi 4.
Saya
So it is impossible. Impossible. Okay. To make a zero overshoot with zero steady state error. So they are the give and take. Give here, take here. Okay. So dia tak boleh achieve both zero steady state error and zero overshoots. Okay. So how to do that? So we have to apply a controller. Okay. We have to apply a controller. Next question. Steady state error is an important criteria. Is it possible to determine the value of K so that the system is maintaining the zero steady state error? Explain your answer. Okay, so like I mentioned just now, okay, for part 3, possible due to closed loop 5. Should be critically damped or overdamp. Critically damped is zeta equal to 1, overdamp zeta equal to greater than 1. It only can be achieved with K not equal to 1. Okay. But USS 0 cannot be obtained. Okay, we have a break for a while, 10 minutes. Okay, guys, 10 minutes break.
Okay.
Okay, we continue. Second part, question number 3. Norafika, tolong bacakan question number 3.
Given the following pole plots in figure question point 3a, find the system damping ratio and natural frequency. Sketch the output response of the above system. Comment on the shape of the response obtained. B. A unity feedback system in figure question 3b has an open loop transfer function GS1 equal to 1 over 4s square plus 1. Using the Routh-Hurwitz criterion, identify the region on the S-plane where the closed loop poles are located. C. Transportation system that use magnetic levitation can reach very high speeds. Since the contact friction is eliminated, electromagnets can produce the force to elevate the vehicle. In figure question point 3c, RS represents a voltage proportional to the desired amount of elevation, and CS represents a voltage proportional to the actual amount of levitation. Determine the range of gain, K, to keep the closed loop system stable.
All right, thank you very much. Okay, guys. So how we going to solve this? Find the omega n and zeta. So this is the S plane. Okay. Hidayah,
Yes,
macam
Prof.
mana nak cari zeta and omega n? It just give us this value, this figure only. Yeah.
Hypotenuse.
Sorry, kuat sikit.
Guna hypotenuse yang triangle tu. Theorem Pythagoras.
Theorem Pythagoras. Yang mana?
Ya. Tu yang negatif 8 tu kan dekat tengah dan
Okay.
doktor hari tu ajar tu. And then kita buat theorem Pythagoras lah because negative z because zeta omega n is equal to real negative real begitu bukan?
Gua cakap ni tak faham. Aisyah Syahira, tolong Budak muar. Aisyah Syahira.
Yes, Prof.
Dia punya kompleks conjugate force tu berapa?
Negative 8 plus minus 5G. Yeah.
Okay. Okay. Omega D is 5. Omega N and zeta, Syahira?
Sekejap doktor.
Lambatlah jap-jap ni. Soleha. Soleha.
Yes, Prof.
Omega N and zeta. Ni apa? Soleha.
Oh, origin.
Origin. Okay. Ni garisan apa?
Hypotenuse.
Ha? Hypotenuse benda ni.
Bukan.
Tak faham saya apa benda. Saya tanya line ni line apa? Tak tahu. Nur Najwa. Line ni line apa Najwa?
Tak tahu doktor.
Omega n.
Omega N. Eta? Nur Najwa? Kan? Jadi omega n sama dengan apa? Najwa? Nur Najwa, omega n sama dengan apa? Ni panjangnya 5, ni 8. Bukan weh. Nampak tak? Nur Najwa?
Lima kuasa 2 tambah 8 kuasa 2. Dan dapat jadi 9.434.
864.
Betul? Di set.
Jadi omega n set
Set 89.
berapa?
9.434.
Okay. So that's why zeta omega n sama dengan 8. Zeta equal to 8 divided by 434 equal to
Equal to 0.848.
848. Okay. Omega D 5. Omega N is apa tadi? 9.434. Okay, zeta equal to 848. Kan? Right? So kita dah tahu dah. Is a second order system. Okay? So dia punya respon macam mana? Nur Najwa? Respon dia?
Under jam.
Yalah, ini graf dia, rupa dia.
Oh. Graph dia. Under jam response.
Yalah, macam mana rupa dia?
Macam dalam assignment.
Sini, kan? Betul?
Betul.
Okay. Any question? Henrietta, any question? Henrietta?
No question.
No question. Huh?
Yeah, no question.
No question, Bah. B as an open loop transfer functions, GS, process criterion, okay. Okay, right.
Yeah.
Macam mana nak buat B? Fine. Closed loop transfer function. Okay. Henrietta, bacakan dia punya tu. Open loop ni.
Open loop. 1 over 4s squared. 4s squared times bracket s squared plus 1. Close bracket.
Yeah. So this one is open loop. Closed loop.
1 over 4s squared open bracket s squared plus 1 close bracket plus 1.
Nur Aina Najia. Nur Aina Najiha.
Yes, Prof.
Double A at the front, double A at the back.
For yes, Prof.
4.
Yes, Prof. 4s squared bracket s squared plus 1 close bracket plus 1 equals to 0.
Equal to 0. Kan?
Yeah. Yeah.
Simplify.
4s to the power of 4 plus 4s squared plus 1 equals to 0.
Okay. Crossways table. Jenel. Jenel Arif.
Yes, Prof.
Awak yang Arif kan?
Ya, boleh.
Dengar lah suruh kau. Kuat sikit.
Ya.
Tak dengar. Awak tak dengar. Syairah, tolong Tolong Jenal.
4
4
0
Hah?
0 bukan
4
0 ke 4 terus 0 4 0
0
1 0.
So what happened now? What happened now? What happened now? Sharifah, what happened now?
0.
What happened now? Apa yang berlaku ni?
Rows of 0.
Ah. Tak datang. Bercabut. Apa yang berlaku? Medinik Herman, apa yang berlaku?
Row of zeros.
So kalau row of zeros, what is the procedure? What is the procedure? Herman? Find PS, the auxiliary equation above ROZ, which is 4 kan? Then differentiate. Herman?
Yes, Prof.
Differentiate.
Differentiate for 16s cube plus 16s for 8s.
Okay.
Yeah.
So 16 and 8. Okay. So 16 and 8 will be, sorry. This one. Ganti sorry. Okay. Boleh tak?
Boleh, Prof.
Okay, teruskan.
Boleh,
Yang
Prof.
Ni apa? Fatihah. This one.
Using determinant.
Using determinant. Okay. Silakan.
4
4
16 8 over 16. Terbalik, Doktor. 4 16 8.
4 16. Oh, baca begitu.
Macam tu.
Oh, ya. Oh, bahasa Rumi Saya pakai bahasa Jepun. Okay, 4, 4, 16, 8.
Over 16
Hmm.
equal to equal to 2.
Tunjuk dulu.
Oh,
32. This one.
32, 64.
So,
Equal to 2.
what? No. Positive 2.
Positive
Kan?
2.
Positive 2. Yang ni?
4, 1.
Sekejap. 4,
1.
1.
Bawah tu 16.
Okay.
That's the one.
16.
16. 0.
0. Divide by?
Divide by 16.
Divide by 16. Sama dengan?
Sama dengan 1.
Positive 1.
Positive 1.
Yang ini 0. Betul?
Ya, betul.
Okay.
Okay.
Terima kasih, Fatihah. Yang ini?
Sama.
Daniel. S power of 1.
Yes, Prof.
S power of 1. Macam mana?
2. Tak tahu, Prof. Itu.
Tanya Fatihah.
Ya, saya.
Dia tak tahu. Tolong dia.
Okay. Kita baca Rumi ya, Doktor.
Rumi lah.
8, 2, 1 over 2. Final answer is 4.
Over 2 eh?
Okay.
So this one is 16.
Tolak.
16.
16.
Apa yang tu je? 0.
0 betul lah. Oh, salah key. Betul lah, saya salah key.
0.
0.
0.
0.
Yang ni pun 0 juga kan?
0 juga.
0 juga. Sekali lagi Aruzi. Sekali lagi Aruzi. So the procedure is?
Find PS.
Find PS.
And then differentiate PS.
So PS dia is above the second Aruzi lah, which is this one. 2S square plus 1.
So it will be 4S.
Sabar Kak. 4S. Okay. So 4S will be here lah. Okay. That's why you kata
4. Sebab tu.
Kau tak tahu di sebaliknya tu. Di sebaliknya tu ada Aruzi.
Lupa nak mention. No, first.
And Rita, the last one. Last but not least.
Determinant.
Determinant.
Negative 2 minus 0. Sekejap. Saya kira terus lah.
Kira terus bah. Terus lah bah.
Kejap. 1.
Mesti satu. 4. So saya panggil pakar. Sign of change. Nur Najwa. Pakar dia.
No signs of change.
Nanti lah belum tanya lagi.
Okay.
Belum tanya lagi. Positif. Positif kan? Ada sign of change? Hello? Ada sign of change?
Tak ada.
Tak ada. So maknanya if there is no sign of change, meaning that ayat sikit. No sign of changes from Ruth Lewis table, kan? Meaning no closed loop poles at RHP. Okay. Then, hello guys, boleh tak?
Boleh, Prof.
Okay.
Yes,
Okay.
Doctor.
2 times ROZ. What does it mean? Tafsirnya apa? Tafsiran.
Saya tak ingat.
Tak ingat.
Soleh,
tolong ni.
Yes, Prof.
Kawan dengan Balkis kan?
Yeah.
2 times ROZ, meaning that baca lah.
4 closed loop poles at the imaginary axis.
So, kalau kita lihat kepada apa nama ni tadi, characteristic equation tadi tu, Henrietta, can you read for me the ni kan, Henrietta? Betul tak?
Ya, betul.
Betul tak?
Betul
Henrietta,
Pak Prof. Ya, betul.
kamu pakai kalkulator apa, Pak? Warna hitam ke warna putih?
Warna putih, Prof.
Boleh kamu carikan roots dia?
Kejap, Prof. Um, 0.707.
Zero?
J 0.707. Plus minus.
Bisa tu?
Itulah dua Prof. Satu positif J 0.707, satu lagi negatif J 0.707.
Ada 4 kan?
Ada satu je kan?
Dia kan S power of 4 ada 4 roots.
Ya.
Betul?
Ya, betul.
Jadi ada 2 lah. Multiply by 2 lah, ada 2 kali kan? Ada 2 kali. Okay, so dia berada di sini. Dia bertindih. Okay. Last question. Last question. Panjang soalan ni. Okay, range of K. Again, kita kena guna rule twist. So this is the controller, this is the plant. C. Ahmad Zulizat. Ahmad Zulizat. Tak datang. Farid Rizwan.
Yes, bro.
Forward transfer function. Bacakan controller tu.
K S plus 0.8 S plus 10 over S over S.
Over S. Multiply.
Multiply 7,500.
7,500.
I see. Over S plus 60 S minus 60.
Dah.
Dah tu je.
Okay. Closed loop transfer function. Amizi.
Yes, bro.
Closed loop transfer function.
7,500. Oh. S plus 0.8.
Tak dengar.
7,500 S plus 0.8 S plus 10 over S plus 15 S minus 60 plus 7,500.
Okay. Rida Hadira. Rida Hadira.
Saya.
Characteristic equation.
Tak sempat salin tadi, Prof. Tadi slide tadi.
Tak sempat salin. Kesian. Baca kan?
S plus to the power of 3 plus 7,500 KS square plus C
Baca.
8100 K minus 5,500 S plus 60,000 K equals to 0.
Okay. So rows table. Rida Hadira. Rows table je. Satu.
7,500.
Okay.
Lepas tu
81,000.
1,000 K tolak
Tolak 3,006. Bagi dengan 60,000 K.
2,000 K.
Okay. Ni expert dia Fatihah.
Ya, saya.
Fatihah. S01.
One. Oh, nak final answer terus ke?
Final answer lah terus. Awak yang pakar sekali.
Saya answer.
Saya makan coklat dulu. Okay.
7,500 K. What is 7,500 K in bracket 81,000K minus 3,600. Close bracket. Minus 60,000K over 7,500K.
Wow. 750. Okay. Panjang kan?
Panjang.
Panjang lah. Ini kalau suruh pelajar kira ni, ambulan akan datang UTM. Bawa pergi ICU. Soalan susah, bukan saya punya soalan saya tak buat soalan ni. So, dia punya teori dia apa? Aisyah Akram, teori dia apa? For stability.
Oh, teori dia adalah which is the range in between 0. Kalau stability in the range of 0 from 0 until a minimum from maximum value.
Alah.
Kita dapatkan K dulu. Lepas tu equation satu, equation.
Akak, teori dulu Kak.
Teori. Siap.
Nur Najwa. Apa teori dia?
First column must be more than 1.
More than 0 is more than 1.
Oh. Okay.
More than 1. First column coefficient must greater than 0, bukan greater than 1. Okay. So kalau kita tengok sini, ni dah more than 1. More than 1. More than 0. More than 0. More than 0. Jadi kalau ini more than 0, maknanya K greater than 0. This one K greater than 0. So tinggal yang ni. Yang panjang. Betul tak? Fatihah, betul tak?
Betul.
Okay. So nanti simplify. You akan dapat K 0.044. Di range dia. Kan?
Bukan K more than 0.044 ke?
0.044.
So, dia punya sign tu kena tukar, bukan ke? Patutnya kena tukar sign. Dia K more than 0 and K more than 0.
Negatif tu kan nanti dia. Sorry.
2.044.
Hidayah.
Yes, Prof.
0.01 stable, unstable, marginal.
0.01 stable.
Stapler.
Stable.
Stable. Easy. Easy.
Yeah.
Easy.
Yeah.
K 0.5 stable, unstable.
Unstable.
Other case?
Yes, Doctor.
0.044. K sama dengan 0.044. Stable ke unstable?
Yes.
Apa yang yes? Stable ke tak stable?
Oh, stable.
Alah.
Oh, no.
Marginally stable.
Imaginary statement. Okay. Habis soalannya. Dah pukul berapa dah? 3:40. Dah habis lah. So next week kita continue. Any question? Ada soalan? Ada soalan?
Ada.
Silakan.
Tapi
Yang tadi kita bincang, ada soalan?
oh dah kan. Kalau tadi tak ada Prof.
Ada. Saya ada soalan. Fatihah ada soalan?
Tak ada. So far faham.
Okay.
InsyaAllah.
Saya ada satu soalan.
Oh ya.
Fatihah boleh ya?
InsyaAllah boleh.
Soalan ni bukan soalan kontrol. Soalan lateral thinking.
Okay.
Saya nak tanya scorpion warna apa? Di color apa scorpion?
Warna hitam.
Salah.
Hitam.
Salah. Scorpion warna apa? Color
Warna
apa?
ginger.
Mana? Scorpion
Orange.
warna hitam.
Oh, bukan dia warna hitam ke? Warna hitam kan?
Scorpion bukan color hitam.
Oh.
Scorpion color jengking.
Saya jumpa warna hitam.
Scorpion adalah color jengking. Aisyah. Aisyah. Bukit dalam bahasa Inggeris apa?
Mountain. Bukit. Hill.
Hill. Okay.
Hill.
Can you name one hill that very hard to climb?
Very hard to climb. Hard hill.
Name one hill that very difficult and hard to climb.
Tolonglah.
Saya nak tolong.
Doktor nak jawab.
Mustahil.
Mustahil. So Aisyah, you are too much study. Kita tak boleh tengok dah, tak boleh fikir.
Yes, bro.
Sangat dalam hidup ni.
Betul.
Mustahil is there. Okay, itu saja. So I see you next week. Thank you very much for your participants. We will continue until revision week lah. Okay.
Okay, thank you, Prof.
Thank you.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.